All right, welcome to your YouTube Maths stream. This is Udesh from Easy as Pie, and we've taken a 2-week break due to the amount of school holidays and holidays in general. So, welcome back, and I hope you will find benefit from this. So what I'm going to do is I just want to see how this connection is. Connection seems fine. And we will be starting in a bit. But what I need to do is I just need to click on the stream here and just have a look at the stream health. So it says that the stream health is excellent, but my sound, why is my sound? Oh, there we go. That's why. All right. So I'm going to minimize this and I'm going to maximize this. And I'm just going to say something in the chat. Hello, class of 2022. All right. So what we're going to do is we are going to do a question based on differential calculus, and I am going to take you through the questions in this case, and I encourage you, if you are joining and you have anything to say, please do so. Please ask questions. And so let's see what this question says. Right, determine f dash of x. So they want the first derivative from first principles. Okay, if it is given that f of x is 4 minus 7x. Now, the moment that I am told that I need to derive from first principles, what I need to do is I need the formula for derivation from first principles. So that's what I'm going to get next. Okay, and if I bring out the formula, right, hopefully by now you should know that first principles uses this formula here. It's the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, so what we're going to do is, I'm going to show you a couple of steps. Now, the first step, okay, is going to be, and this is not something that you have to write in your exam, that's why I put it in green, but let's find the derivative just using our shortcut rules, right? So if I find the derivative just using my shortcut rules, I know that the derivative of a constant is 0, and the derivative of x in this case will just be equal to minus 7. So you can see I'm expecting minus 7 here. Now the reason why I've put this in is because this is going to be a nice check to see if you're on the right track when you're working through this, right? So now let's go for step 2. And so the way I like to set it out is I like to say, okay, let's work out f at x plus h. Now, in terms of the functional notation, what does this mean? This means wherever I see x, I will replace it with x plus h. So f at x plus h becomes 4 minus 7. And where I see x, I'm going to put the brackets in x plus h. X plus h. Okay. And of course, what I'm going to do is I'm then going to distribute what I have. So I then get 4 minus 7x minus 7h. Okay, that's step number 2. Step number 3, then I'm going to say, okay, what is f at x plus h minus f at x? Okay, and that's going to be equal to this thing here. So 4 minus 7x minus 7h minus, and then I'm going to open a bracket. And f of x is this thing here, so I'm going to say 4 minus 7x. Okay, and I'm going to simplify this one. So if I do the distributive law, I then get 4 minus 7x minus 7h minus 4 plus 7x. And so now what you'll notice is I can do a little bit of cross cancelling here, because 4 minus 4 cancels out to 0, and then minus 7x and plus 7x cancels out to 0. And what am I left with? I'm left with minus 7h. Okay, let's go to step 4. And then I'm going to say, okay, let me put this definition in. So I'm going to say f dash of x is equal to the limit as h tends to 0 of f of x plus h, right, minus f of x. So we know that's minus 7h all over h. Okay, and lo and behold, you'll notice that in this case, the h's cancel, right? And then I can bring in the limit because there is no h any longer. And I get minus 7. All right, so this is how I would recommend you break it down. And what you'll notice is you can see that I can compare what I did in green to what I did in black, and they're the same. So I know I'm on the right track. And that is how I do this. So I just want to see, okay, here we go. There we go. So hopefully no questions here. And this is a typical first principles question. So let's move on. Okay, and I put the answer here. So 4 minus 7x is f dash at x. Okay, you can see they put the definition. They've done it all in one shot or one step. What I would recommend is do it in this way because it minimizes the odds of making a mistake. Okay, so 7.2, right? Let's have a look. Determine dy dx if y is equal to 4x to the 8 plus the cube root of x, sorry, the square root of x cubed. Now, the first thing that we need to do is we need to put this into a form that we can differentiate, right? So for 7.2, I can then say y is the same as 4x to the power of 8. Nothing changes there. And then what I'm going to do is I'm going to say this is x cubed raised to the power of half. Okay. Now, the reason why I've done this is because this is the only way I would be able to differentiate this using the tools that I currently know. So then I say this is 4x to the power of 8 plus x to the power 3 over 2. Now, you'll notice that in this case, I have to know my exponential laws really well to be able to simplify this. So now that I have this, I can then say, okay, let's differentiate y with respect to x. And in this case, this becomes 32x, and this becomes plus 3 over 2x. So the 3 over 2 goes to the bottom, and then I take away 1. So 3 over 2 minus 1 is 1 over 2. Okay, and I've got it in positive exponents, so this then becomes my final answer. Okay, and you'll notice I've got, 32x to the 7, right, because that 8 goes down and then I take out the 1, right, 32x to the 7 plus 3 over 2x to the half, and that is my answer for 7.2. Okay, nothing difficult so far, nice and simple, nice and easy. Easy marked, provided you understand and you knew how to do your exponent laws. So let's remove this now, because this is done. Okay, and let's have a look at the next one. So we're given y is equal to ax squared plus a, right? And they say determine the derivative of dy dx, right? Now remember, dy dx is differentiate y with respect to x, right? So in this case, if you look at the x squared, we know that 2 will come down, so that becomes 2a x, and then I take away the 2, or take away 1 from the 2, and that becomes x to the power 1. Now, with respect to x, a is a constant, and we know that the derivative of a constant is 0, right? So in this case, your dy dx is going to be this answer here. Okay, that's your answer. Okay, nice and simple. Now let's go for the next one. So now if they want me to differentiate y with respect to a, then I'm treating a as the variable and x as the constant, right? So if a is the variable and x is a constant, that's like the constant in front of the variable. So this then becomes x squared, right? And then this a, so if I differentiate with respect to a, that then becomes 1. And that is my answer. Okay, x squared plus 1. So it's important to understand what they're asking you to do when they say differentiate y with respect to x and differentiate y with respect to a. That's super important. Make sure you get that on the money if you can. Okay, so this as well, not too difficult, nice easy marks. So let's go to the last question, which is maybe the more challenging question. Okay, they say the curve with the equation y is equal to x plus 12 over x passes through the point a to b. And then they say determine the equation of the line perpendicular to the tangent to the curve at A. Now this is for 4 marks. Now if you look at this equation, right, it looks like it's nothing we've really seen before because, well, this 12 over x looks like a hyperbola and this x looks like a straight line, and we don't know what we get if we combine a straight line and a hyperbola, right? But maybe the way to actualize this or visualize this is let's just see what we have, right? So let's just draw a Cartesian plane here, right? You don't have to plot any points, but let's start by plotting the point A, 2 and B, right? So let's plug that in. So what we can say is, we can say, and this is going to be my step 1, we can say B, because remember B is your y and A is your x, is equal to 2 plus 12 over 2. Okay, so that becomes 2 plus 6, which is then 8. So the point A is 2 and 8. Okay, and let's put it somewhere here, right? So let's say that's 1, 2, let's say that's 1, 2, 3, 4, 5, 6, 7, 8. So let's say it's somewhere around here, right? And let's say this curve goes something, it doesn't really matter, but let's say it goes something like this, okay? Something like that. Now remember, like I said, we don't need to know what the curve actually looks like, right? What we need is we now have this point A, right? And we know this is the point 2 and 8, right? And then they want the equation of the line perpendicular to the tangents to the curve at A, okay? Now, let's draw the tangent in red. So let's say the tangent is coming down like this, for instance. Okay? Now remember, this will have some equation, y is equal to mx plus c. Okay? And how do we get the equation, or how do we get the gradient of this red line? Well, very simple, and I'm going to do this in red, right, because we're working with the red line. What we can do is we can then work out the derivative with respect to x. So we can say, okay, dy dx is equal to what? Now remember, actually, before we do that, let's just modify this such that we can find the derivative easier. So we can say that this is y into x plus 12, x to the minus 1, right? Because I'm using my exponential laws to bring this x to the top. And now it's easier to find my derivative because I can say differentiate y with respect to x. This becomes 1, and that's minus 12 x to the minus 2, right? Which is another way of saying 1 minus 12 all over x squared. Okay, now remember, if you think about it, we have the point 2 here, and we can plug it in here to get the gradient of this red line. So what we'll do is we'll say, okay, let's plug in. So we can say the gradient in this case is going to be 1 minus 12 all over 2 squared, which is 4. So that becomes 1 minus 3, which then becomes negative 2. Okay, so we now know that this equation is actually minus 2x plus c, right? And they want the perpendicular, right? Now let's do the perpendicular in green, right? They want the perpendicular to the tangent to the curve at A. So the perpendicular is here. Okay, the perpendicular is here. Okay, and so this is also going to have some equation y is equal to mx plus c. Now what do we know about the relationship between perpendicular lines? Well, we know their gradients must be equal to -1 when I multiply them. So if this gradient here is -2, I then know that this gradient here has to be a positive half, and that's a positive half x plus c, right? And that's how I get the gradient of this green line. But they want the equation of the line. Now, how do I get the equation of the line? Well, what I'll notice is this blue curve, red curve, and green curve are all intersecting at the point 2, 8. So what I can do is I can then substitute 2 and 8, and that's y, and that's x. So where I see y, I say 8 is equal to half times 2 plus c. And from here, that becomes a half times 2 is 1. I take that across, so c becomes 7. And therefore, the equation of the line perpendicular is going to be y is equal to half x minus 7. And that is my final answer over there. Okay? Now, you'll notice I broke it down into a nice step-by-step way, and you'll notice that I created a picture here. It is always a good idea to create a picture, because a picture will help you to better see the thing that you need to solve, and it will help you to get it and break it down into a step-by-step manner. Okay, let's have a look at the model solution. But you can see I've got exactly the same answer, and you can see they would have done it, but they didn't draw anything here, right? But it doesn't matter, right? And this is my answer. So, nice, short and sweet session, okay? And I think I am going to leave you at that for today. I encourage you to revise this and practice, right? Practice these exam type questions. They will help you in the long run, not only in school, but in varsity as well. I'll see you next time, next week. Ciao.